Hello class, today we are on day 2 of adding and subtracting rational expressions. So the essential question is, how do I add or subtract rational expressions? The learning intention, I am learning to add and subtract rational expressions. So you've got 2 warm-up questions where you're simplifying, and you've got 1 where you're multiplying. So please pause the video and see if you can do those on your own. Pause the video now, please. I hope you tried to work them out. So I'm going to look on simplifying. I'm going to see what is my greatest common factor. Here it is 35. So if I factor out 35, I am left with x minus 1. I've got 25 and I've got 40. The greatest common factor of 25 and 40 will be 5. 25 divided by 5 is 5, followed by the x, minus 40 divided by 5 is 8. Okay, so as I'm looking, I've simplified this. There's nothing else that's alike top and bottom, but I know that 35 divided by 5 is 7. So this would be 7x minus 1 over 5x minus 8. As I'm looking at this, x cannot be equal to. Okay, I would add 8 and then divide by 5. So that's positive 8 over 5. You'll have, if you graph it, you will see the graph is really, really close, but will never touch the point positive 5/8 on the x-axis. Okay, for the next one, let's look and see what's going on with it. Okay, what are my factors of 5 that add up to 6? Both are positive. Factors of 5 that add up to 6. Well, there's only 2 factors of 5, and that's 1 times 5 gives me 5. 1 plus 5 gives me 6. So this is over 1 and over 5. X plus 1, or I guess this should be n, not x. So this is n plus 1. As I'm looking at simplifying, I've got n plus 1 on top and on the bottom. I can factor them out. Those are the same number. So this simply ends up as n plus 5. Okay, I know that n cannot be equal to. What's the opposite of positive 1? Negative 1. Okay, any questions? Okay, if you're still struggling, go back through the video and watch it again. Always, always, always factor out your greatest common factor and then deal with what's left. Okay, we're going to multiply. As you're multiplying, you want to see what you can eliminate. So I'm looking at top and bottom. I've got n minus 8 up here, n minus 8 down here. Those are gone. Or x minus 8, x minus 8. That's a number divided by itself. I've got x plus 10 and x plus 10. Those factor out. What do I have left? On the top, I have 4x. On the bottom, I have x plus 6. And I'm done. But I still have to list my constraints. What can x not be equal to? I have 1, 2, 3 constraints. I go back to my original problem. The opposite of 6 is negative 6, or the opposite of negative 8 is positive 8, or the opposite of positive 10 is negative 10. So it can't be negative 6, negative 10, or 8. When you add and subtract, as long as you have the same denominator, you're in good shape. You just have to add what's on top. Five plus 5a plus 1 over a squared plus 3a plus 2. You've got the same denominator. You don't have to change anything. Okay, 5 plus 1 is 6. So this is 5a plus 6 over a squared plus 3a plus 2. Ordinarily, we would not have to factor the bottom, but because we need to know our constraints, we need to factor a squared plus 3a plus 2. So we're looking at factors of 2 that add up to 3. Both are positive. So that's 1 and 2. So as I factor this out, 5a plus 6 over x plus 1 times x plus 2, because that is what that should be a plus 1 and a plus 2. Okay, I need this because I have to look at my constraints. What can a not be equal to? The opposite of positive 1 is negative 1. The opposite of positive 2 is negative 2. Those two numbers will not work because we cannot divide by 0. Okay, pause the video here and look and think about the process we just went through. When you're adding, it's easier than when you're subtracting because you do not have to worry about changing any of your signs. Okay, so as we're looking at the next one, we know that we can always make that common denominator by multiplying these two numbers on the bottom together. So 6 over x minus 1. I'm going to multiply top and bottom by x minus 8. For the next one, minus 4. I'm going to multiply the x minus 8 by the x minus 1. What I do on the denominator, I have to do on the numerator. Now I've got the same denominator. I am ready to simplify. Distributive property. 6 times x is 6x. 6 times negative 8 is negative 48. This time I'm going to use the negative 4. So I don't have to change signs. Negative 4 times x is negative 4x. Negative 4 times negative 1 is positive 4. The denominator stays the same. X minus 8 times x plus 1, minus 1. Okay, I have rearranged. If you don't need to rearrange, do not put it in your notes. If you understand how to go from here to the final, that's great. If you don't, put that intermediate step in. 6x minus 4x is 2x. negative 48 plus 4 is negative 44. And this is all over x minus 8 times x minus 1. Okay, if I needed to, I could simplify this down, but if I simplify, I know I'm still not going to have a common factor. Because if I pull 2 out, it'll be x minus 22, and I do not have that in my denominator to factor out. But I do need my constraints. X cannot be equal to, I go back here, the opposite of negative 8 is a positive 8, or the opposite of negative 1 is a positive 1. And I am done. We're creating that common denominator by multiplying the two that we have here together. But if you're looking, x minus 8 over x minus 8 is 1. It's the same number dividing by itself. So what we're actually doing is dividing by a number that is multiplying by a number that is equal to 1. Because when you multiply by 1, you don't change your number. Okay, if you need to review, that's great. Back it up and watch it again. Oh, this one looks really weird. Okay, first thing I've got to do is simplify the bottom fraction. So I am looking at 1/5 minus 4/25. Okay, so if I'm looking, is 5 a factor of 25? Yes. So that means my least common multiple of 5 and 25 will be 25. So I've got to change this into something over 25. This one will stay the same. What do I multiply 5 by to get 25? 5 times 5 gives me 25. 1 times 5 gives me 5. Okay, so let's get started. 25 over 4 divided by 5 over 25 minus 4 over 25. All I'm doing is working with this bottom fraction. It's in parentheses. So 25 over 4 divided by 5 minus 4 is 1, 1 over 25. Okay, now pause there for a minute. You've got a fraction and you're dividing it by another fraction. Do we divide by a fraction? No, we multiply by the reciprocal. So let's see what this looks like. I've got 25 over 4. Instead of dividing by 1 over 25, I'm going to flip that over. 1 over 25 becomes 25 over 1. This is where I would use my calculator, because 25 times 25 is 625. And it's still divided by 4 because you're multiplying here. So, can I divide it by 4 and get a whole number? No, I cannot. But I do know that 0.25 is 1/4. So this is equal to 156 and 1/4. If I want to change it to a decimal, I'll hit my math button, I'll hit enter, enter. Oh, there's my fraction, I can't simplify from there. Math button, go down 1 for my decimal. There we go, the decimal becomes that fraction and we're done. So, any questions on all that craziness we just did with the fraction? Okay, so now let's think a little deeper. I am not going to go through the next problem with you until you think about it. How do we split this into the sum of two rational expressions with unlike denominators? So we want to factor and then figure out how we get this number up here. Okay, what are our factors of 2 that add up to 3? We did that on the other side. Our common factors will be x plus 2 times x plus 1. Okay. So those are the two denominators we're going to use. What will be our numerator? Okay, let's think logically. What happens if instead of multiplying I add? I've got 1x here, I've got 1x here, that gives me 2x. I've got 2 here, I've got 1 here, that's plus 3. Which means if I put a 1 up here, it will work. Because you're going to end up multiplying this by x plus 1, which is where the x plus 1 comes from. You'll multiply this by x plus 2. So when you add them together, you will get 2x plus 3. Just a different way of thinking, a little bit higher up than what we normally do. But I do want you thinking those ways to try to understand why things work. So if we're going to simplify the next one, I've got to multiply by the other denominator. So a over b will be multiplied by d over d. Then I'll have bd on the bottom. Then c over d has to be multiplied by b over b. So I've got bd on the bottom. So this is equal to AD plus BC all over BD. And we're done. So I know I'm successful. We know that B cannot be equal to 0. We know that D cannot be equal to 0. Up here we know that X cannot be equal to -2 or -1. I did forget to put my constraints. Anyway, I know I'm successful when I can add, subtract, multiply, or divide rational expressions. Or add or subtract rational expressions. Remember that common denominator.